Howdy folks, today we have this crappy solid state Traynor 15 watt thing, DG15R I think it's called. It's not crappy, it looks alright. Uncle Doug would be proud. Look, this isn't even an old amp. However, something's missing. Anyway, it's got a reverb tank in it, a real one, and I think it still works, and it's got a 10-inch Celestion. I know it's pretty crappy. Look, I bought this thing for a few dollars on Facebook Marketplace, not working, with the plans of, okay, let me see if I can get it started, get it up and running, you know? And if it did work, hooray, I've got a cheap little solid-state amp I'll probably just whack on eBay as a working amp. Or, if I didn't get it working, rip the chassis out, guess what? 10-inch combo, two 6v6s, a la Princeton. And I would probably do it point-to-point wired. I've got all the parts and bits and pieces I need here. Everything from the power transformers, output transformers, filter caps. What else? Rectifiers. I'd probably just go ahead and buy some resistors that I needed. But, you know, Princeton reverb, 10-inch combo. Why wouldn't you? And just, you know, maybe take this badge off and put a custom-made one on there. So that's the plan. Get a solid-state hunk of junk working, sell it on eBay for profit, or if it doesn't work, and I've only spent like $5 in parts, so big deal, if I can't get it working, it's going to become a custom point-to-point wired Princeton reverb of some description. Let's go look at the chassis and see what we find. So here we are at the workbench. You can see messy as always. I did get rid of all the resistors and capacitors that were here that I chucked out from that other little 6v6 powered radio. You can see here it's a Dyna Gain, 15, Traynor DG15R. Now, Traynor makes good stuff, you know, Yorkville, Traynor, same thing. Their bass amps are killer. So anyway, open this up. I have had a quick look. I sort of skimmed through here, looked at the inputs, looked at the circuit board, and then I got here. Look at that. Look at that fine piece of work. Now this chip here is a TDA2030, which is discontinued. So I have two options. I can get a TDA2050, which requires more voltage to get more wattage, and probably a bigger heatsink. The thing is, it's probably still only going to run at 15 to 20 watts because this circuit here is only going to pump in the amount of voltage that, you know, you're going to get here. I'm not going for more wattage here, but I am trying to find equivalent, whatever this chip is called, op amp or whatever. So this here now from factory is a TDA2030. Now the equivalent I found to a TDA2030 is a LM1875, which is available and is in stock at my local electronics dealer. So I'm going to go for a little ride down there on my motorbike, pick up one or two spares of these, maybe some diodes because they're a couple of cents each. And then before I put them in, I am going to take this circuit board out or leave it in here and just probe it a little bit and make sure that the pins on here are getting the correct voltage. Because this blew up for a reason, and it could be just because these diodes blew up. It could be a capacitor. It could be a resistor that's gone short circuit. Who knows? Because nothing else seems horrible in here at all. So I'm guessing it's probably something around here, and I'm guessing it's these diodes. And definitely you can see a chunk of the chip is completely blown off it. Now, I couldn't find that inside here, so I'm not sure if someone's had a go at this already. But that's what we're going to do. We're going to replace this and replace these diodes and see what happens. Alrighty, I've acquired the new chip, about $7 worth, so let's hope this works. So what I'm going to do now is, well, good old modern circuit board amplifiers. I'm going to have to take off this screw. I'm going to have to pull off each one of these, and there's more, and these. And then there's a nut underneath each one of these I'm going to have to undo and take off, and then I'll be able to pull this out. Now, I'm also going to have to undo each one of these jumper cables. There's about 5 or 6. And finally I'll be able to get this out. And then I'm going to have to undo that screw, and there's screws on the bottom side of these that go into these holes, but on the opposite side of the heatsink that are holding the heatsink in place. Undo all of that, And then finally, I'll be able to get the board out. Well, I'll get the board out and then undo this. I'll then be able to unsolder the diodes, unsolder the IC. Now, remember, as I said, the one in here is a TDA 2030. They don't make them anymore. So this one is a LM1875T. Don't know what the T stands for, but this is a TO220 package. This is what they look like. So you can see the legs are already staggered. So all I have to do is desolder that after I've undone all this. Desolder that, pop this in, resolder it back in, and Bob's your uncle. All right, so I thought, you know what? I'm kind of rushing ahead here. Let's just take a breath and slow down. I've plugged the amp in. Now, I don't have any load connected to it. This is a solid state amp. You don't really need to connect a speaker load to it. So I'm going to flick it on, and I thought, hang on. You know, I started pulling things apart, and I thought, hang on a sec. Let's see what the voltages in here are doing, because now it's all well and good to just go in here, gun-ho, start replacing bits that are blown apart, you know, and you look in here and you go, shit, look at that thing. I thought to myself, hang on. Why did that happen? Okay, now here's where, now my training from years ago, I'm not an amp expert. Don't get me wrong when you watch these videos, and you know I'm learning, and it's because I watch guys like Uncle Doug and D Labs and Mr. Carlson's lab. You know, they're the geniuses. They're the real deal. I'm just a hack. And especially when it comes to solid state stuff, I don't know what the fuck's going on. But I do know that most solid state stuff, you've got a plus and minus voltage. So what I'm going to do, rather than ramble on about this, I'm going to show you some things that I'm going to do. Now the reason I'm doing this, and this is why I pressed record for this part, is you've got some black marks here, okay? And you can see a transistor is blown. The main transistor that makes everything freaking work in this amp. This is blown up for a reason. And we've got some black marks around the diodes here, right? So no, the black marks around the diodes could just be that, you know, this thing blew up and let out the brown smoke. It could be. But I'm not going to guess, because look, man, I just spent $7 on this. That's a $7 gamble. I already paid money for this amplifier in a broken state that doesn't work. And you know, at the end of the day, what am I going to sell this for, $100? Now, if this doesn't work, like I said, I'm going to turn it into a valve amp. It's not going to cost me any extra apart from parts I've already got laying around. But I want it to work to begin with, because then I can just chuck it back on Marketplace and make some money off it. You know, or sell it to a student and they can do something with it. Little practice amp is perfect, especially, you know, this is pretty cool. It's got dual channel, it's got an overdrive channel and a clean channel, it's got built-in spring reverb, it's got a CD input, you know, they can connect their iPod to or their computer to and play music off it and jam to backing tracks. It's got a high and low input for high gain and low gain pickups, active and passive and that sort of stuff. And I thought, you know what, this is a pretty good little honest amplifier. What my point is that I want to test this. You don't want to go in here spending, you know, nearly $10 on a new chip, plug it in and find out it blows up again because something else around here is stuffed. What I'm going to do is I'm going to turn this on. I'm going to connect my probes up to here and see what sort of voltages we're getting on the pins that are currently here. What I'm looking for is about plus or minus 15 volts. Plus and minus 15 volts, I should say, and here's where I get that figure from. So here's a schematic. Now this doesn't really tell us what voltages are on here, but I've zoomed in on the section that I need to. Here are those two diodes, and here's the TDA 2030. Now if I scroll up a little bit more, here we go. Okay, if I scroll up. I'm going to zoom out a little bit so we can see the bigger picture here. You can see pin 3 and pin 5 of the TDA 2030, in this case our LM1875. It's the same pin outs, so nothing changes. We got a minus volts, so minus voltage coming in at pin 3, and plus plus voltage, so B plus, coming into pin 5. So technically, if I run my multimeter against pin 3 and pin 5, I should get a potential. Where am I going to get that potential from? Well, check this out. Okay, if we go down here to the schematic, we can see that this side is the plus rail and here's the minus rail. And what do the voltages measure? Plus 15 volts, here we are, and minus 15 volts. Technically, I should be looking at approximately 30 volt potential between pin 3 and pin 5. And that's what we're going to look for now. In the current state, things are stuffed up, things are blown up anyway. So we can do our preliminary testing on things that are blown up and not sacrifice our money and good working chips. If I put my multimeter across here and I see something like 60 volts or 100 volts, then I'm going to stop what I'm doing and I'm going to figure out where that's changing and why that's changing. It could be a faulty filtering cap. It could be a rectifier diode here. This is a full wave bridge rectifier, It could be one of these caps that are bent over. A leg could be shorting out, touching somewhere. Who knows? Could be this resistor right here. I don't know. So we're gonna troubleshoot this little honest amplifier and see what we find. All right, so I've hooked up a little alligator clip to pin 5. So the pins on this basically go 1, 2, 3, 4, 5. Okay, it's only a 5-pin package. Pin 5 is the last one, and pin 3 is the one in the middle. Pin 1 is the beginning, and 2 and 4 at the back. Now I'm going to put my probe carefully onto pin 3. So I should be getting a potential of, 30 volts, remember? Minus 15 and plus 15. Well, you get 30 volts. This is nearly up at 50. It's supposed to be 30, and it's nearly at 50. There's something going wrong there. So we're going to do some more troubleshooting. We're going to trace back from there. I'm going to measure the voltage before the diodes and see what's happening. All right, you're not going to believe the problem I found. So I was just doing some more voltage checks, and I came down here to these two big resistors here, okay? The ones just below these huge caps. And they're basically dropping resistors. They're 47 ohm each. So here's R25 down here on the left, and R26, I believe, on the right. Okay, let's go back to our schematic. So here we have R26 and R25. 1 watt, 47 ohm. Okay, so I took some measurements from there. I'm getting about 20 volts, 20.2 on either side. Okay, so that's that's normal because there's no load happening here. So that hence why when I measured here before, I was getting that 48 volts. 22 to 24 volts plus and minus. Now I started smelling something, and I noticed. Now I'm not sure if this is going to come out on camera or not. Can you see just below that gold band, the bottom left, see how there's like a really faint burn mark? I was watching a spark arc across that to this little Zener diode on the left-hand side. And I don't know if I can get a better view, but see how just below that gold line is that little black tiny dot? It was freaking arcing. It was arcing. Now, I didn't get this on camera, and I'm going to try to, but look, I'll tell you what, now it's probably not going to work. So I'll turn the amp back on. So the amp's back on now. It's not going to do it now, you watch. You go through and you go, oh yeah, that's blown, and you measure stuff here, but then if you follow the power supply back, and this is the main power supply, after these two resistors, these two big resistors here, and then these two Zener diodes, what do you get? You get your plus and minus 15 volts. Now that's probably powering all of this stuff through here, all these other ICs, and there's probably various dropping resistors like, these here. And you'll find, again, you'll find more dropping resistors around these ICs. But you're looking here at the problem, and the cause is right here at the beginning. So I'm going to go ahead and change those resistors. Now, I don't know if I have any 1 watt 47 ohm resistors. I'm going to see what I can find. But I'm certainly not getting my plus or minus 15 volts. I'm getting close to plus or minus 22. And that's relative to ground. So what I've done in this case is I've put my ground meter on my multimeter to ground on the chassis. So if I measure that diode, I should get minus 15, and that diode I should get plus 15. So let's turn the multimeter back on, and I'll show you what I'm talking about. So I'm going to put one probe here, and then I'm going to swap it over to this side. So I'm kind of going to do this while being very careful not to arc anything. Here we go, we're getting 19.8 plus, okay? And then if I go to the other side, well, 19.9 minus, okay? So that's closer to 40 volts, which is exactly what we should be getting. But yeah, now this thing's been switched on for a little bit. Now I'm still smelling something not right. I can't feel any heat when I put my hands in here. So, you know, yeah, that heatsink isn't warm. And I can't feel any heat, but I can smell. And I'm not sure if it's just a residual smell from that blowing up the first time around. But anyway, I'm going to change that resistor. Probably change that one just for peace of mind, because, you know, they're a couple of cents. And we'll continue on. Alrighty, so I got the old chip out. Time to put the new one in. Now, the old one, let me grab this. The old one has some heatsink compound. So that's what we're going to do with the new one. And I just happen to have a very large tube of it right here. So we're going to reapply some heatsink compound, resolder the new one back in, cross our fingers and see what happens. And if it blows up, this becomes a tube amp. Alright, so I've put the new transistor back in here, and I've also screwed it back down, so everything's nice. And I thought, you know what, I'm just going to check the underside of this thing, and look at what I found. Someone's been playing in here before me. So when I look at this, and then we try to find the location, it's these freaking resistors. So we're going to have a look now and check that these are the right ones. It's supposed to be 47 ohm. Let's have a look at the colors. Yellow. Let me get my torch. Yellow, purple, black, gold. So the 47 ohm resistors check out fine. You see that terminal? This is coming off the 47 ohm resistor. So you know what? Either someone's messed with this, or this is how it's come from the factory. Traynor, if you've done this, naughty, naughty. But if a technician's done this, or a backyard jobby, good for you. Good for you for potentially wrecking this amplifier. Look at that terminal. Look how close. Like, that's less than a millimeter. And I reckon me wiggling that around before on the other side when I was probing with my multimeter, that's probably why I was getting 40 freaking volts, plus 40 volts. I'm going to fix up that solder joint and tidy it up and make it safe. Most importantly, let's make it safe. Alright folks, so here's the new amp. Well, you know, the current one on the workbench. Yeah, got it running. So fixed up that solder joint, put the new chip in, and here it is playing through a Strat, so single coil. You're gonna get some interference and stuff. Excuse the squeaking. I'm sitting cross-legged on the floor here. But basically, so here's the clean channel, no reverb. So yeah. Alrighty, so yeah, you can hear the buzzing there, and if I flick it, you can hear that. But if I turn the volume off on the guitar, nothing at all. So, pretty quiet amp. So that's the clean channel. I'll show you the reverb. Let's squeeze over here. So this is reverb on about a third. So there you go there, and I'll flick over, I'll turn the reverb down a bit. This is EQ in the middle. I'm not going to play around with the EQ. Master volume's about halfway. It does get really freaking loud after halfway. I probably wouldn't gig with it, but you know, practice amp, yeah. So this is channel 2. That was on the bridge pickup there on my Strat. But there you have it, ladies and gentlemen. This has now been switched on and been soak testing for the sort of the last hour or two. So hasn't blown up yet. Hey, so sadly that means it's not going to be turned into a tube amp. Oh. Fortunately, that means an unemployed musician like myself, because of COVID-19 and basically all my gigs being cancelled, I've resorted to spending most of my time teaching and most of my time repairing this sort of stuff again. So anyway, long story short, here it is. Traynor DG15R. It's got a LM1875 chip in there now instead of the TDA2030. The reason why, again, just to quickly explain if I didn't earlier, basically because the TDA2030 has been discontinued. It's superseded by the TDA2050. The TDA2050, nothing wrong with it, but I couldn't find one. The alternative is a LM1875, and the 1875 seems to do a pretty good job. Anyway, ladies and gentlemen, thanks for watching. Unusual amp for me to repair. Solid state, 10-inch combo. 10-inch combo is not unusual, but the solid state part is. Hope you enjoyed watching this unusual video repairing a solid state amplifier. I hope my shoe is not in the way of that shot there. It looks like it is. Thanks for watching.